Okay, everyone, welcome to the very last episode of season 8, which is kind of crazy. Like we say, every single season, we're like, how have we already got to the end? But I've really enjoyed this season because we really have asked some pretty big what if questions. And I feel like for some of them, it's been like, it's not really a case of what if, it's a case of when, which is super interesting. Yeah. But then some of them have just been completely philosophical and completely mind-blowing. I feel like we are always asking those like really big philosophical questions on
what I found
our
really
episode
interesting.
Anyway.
What I found really interesting is how timely the pandemic one ended up being, because obviously everything with hantavirus. So I thought that was really interesting. So that's definitely a case of when, which is scary.
Literally.
But literally, like, as all that started kicking off, that episode came out. So very interesting. Today's topic is definitely not something that's ever going to happen, but you know, that's the whole point of this series is the whole what if. But considering this is our last episode of this season, we just want to give you guys a reminder that if you want to stay up to date with us and see what the theme for season 9 is going to be, when season 9 is going to be coming out, etc., please make sure you are following us on Instagram and TikTok at soculturedpodcast, because we will definitely post it there. And we always give you a little teaser of what the season topic is going to be. There may be a slightly longer break because we have very exciting news that Taz is moving back to the UK. So everything's a bit up in the air at the moment because the girl's not even got her flight booked home. So
I've not got my flight booked home, and I don't know where I'm gonna live, and that basically means where are we gonna film? Like, it kind of brings up a lot of questions. So yeah, I mean, if you have been watching or listening, then you're probably like, you know that me and Liv or currently live on the opposite side of the world. But like, I feel like some people don't necessarily know that we're not in the same room as each other. But yeah.
Oh my God, so many people say this to me. Like, they're shocked that we're not in the same room.
Yeah, me too. Because I think because we have like really similar sofa, we've got a really similar backdrop. So it kind of makes sense. But yeah, guys, we are on the opposite side of the world. But I will be coming back to the UK. So yeah, it's kind of exciting. And like, honestly,
it's very exciting.
This is a prime opportunity for you guys to tell us what you want us to see, because you want us to see
what you want to see. Yeah.
what you guys want to see from us. Because like, obviously our season 9 theme might not be solidified yet. So what do you want to see from us? Basically, we always have like really fun ideas, so we'll always bring a fun idea, but obviously we want to hear feedback from you guys. Or if you're happy with the show, please leave us a rating, maybe drop us a follow as well. And even if you want to rep us, obviously we've been pushing the merch fairly heavily on this season because we are,
and we shall continue.
Proud. Yeah, we're super proud of like what we're creating here. And if you want the merch, socultured.com is the place to go. So
yes, definitely. But yeah, I'm really excited for you to come back. I'm really excited to see like what might change with the podcast. Like, I think there could be some really positive things come in. We're very excited. Maybe we could film a few episodes together in person, which would be really exciting. But you never know. It's really difficult with like work schedules trying to fit all of this stuff in. So yeah, me and Taz have had a few BTS conversations about some ideas that we have. So I'm very excited. But before we get into all of that, or we get carried away with all of that, shall I say, don't forget to follow us on Instagram and TikTok. But for now, let's get into the final episode of What If.
Welcome to the So Cultured podcast,
where we explore science and tech unfiltered.
We're your hosts, Liv and Taz, two girls who love STEM and spilling the tea.
Each season, we take on a new theme, whether it's busting conspiracy theories, celebrating women in STEM, or breaking down the science in your favourite sci-fi films.
And of course, in every episode, we spill the laboratory,
where we share your wildest stories from the world of science.
Let's get into this week's episode of So Cultured.
What if we travelled at the speed of light? I don't mean flying in a jet, and I'm not just talking about traveling really, really fast, but what if we actually moved through the universe at the exact same speed as light itself? Now, light is weird. It's one of the only things in the universe that seems to completely ignore the rules that everything else has to follow. Nothing with mass has ever been observed reaching the speed of light, and according to everything we currently understand about physics, nothing ever can. But what if we could somehow push a human being closer and closer to light speed? Well, reality itself would start changing in ways that sound literally just completely made up. Like time would slow down, distances across the universe would shrink, and two people could disagree on whether events happened at the same moment and both technically be right. And the scary part is that none of this is conspiracy theory or just some weird thought experiment like the brain in a vat theory that we spoke about a few episodes ago. This is actual physics explained by Einstein's theory of special relativity. So today, we're asking one of the biggest questions in science fiction and also modern physics. What would actually happen to a human approaching the speed of light?
Oh my God, I'm really excited for this episode because we don't always delve into physics subjects, but this really feels similar to the black hole episode we did, where physics just completely stops behaving in the way that our brain can process. It's just mind-blowing and so hard to get your head around.
Yeah, and it's kind of nice because I feel like we started the season with a what if physics related question, and now we're ending with a what if physics related question, and I didn't even think about that, so I love that. But yes, special relativity is probably one of the best examples of that. It's definitely a theory most people have heard of, but I think a lot of people don't actually know what it is or what it means. So before we even talk about traveling near to the speed of light, we need to introduce the basic idea behind Einstein's theory of special relativity. And fundamentally, the entire theory starts with two really important ideas. The first is that the laws of physics are the same for every observer moving at a constant speed. And the second is that the speed of light in a vacuum is always constant, no matter how fast the observer is moving. And that second point breaks normal human intuition because we're used to velocities adding together. Like, for example, if you throw a ball forward on a moving train, somebody standing outside the train measures the speed of the train plus the speed of the ball. But light doesn't behave like that. Everybody measures light traveling at the same speed, around 300 million meters per second, regardless of their own motion. And once you force the universe to obey that rule, space and time themselves have to distort in order to make the maths work. And this is where we get some of the most famous consequences of special relativity, which are time dilation, length contraction, and something called the relativity of simultaneity. We've actually mentioned some of these ideas before on the podcast in a few different episodes, but this episode is where they all properly come together. So, time dilation basically means that the faster you move through space, the slower time moves relative to somebody else. And this isn't just theoretical, we've directly measured this experimentally using atomic clocks, particle accelerators, and even GPS satellites. There's actually a type of subatomic particle called a muon that should decay incredibly quickly, so quickly that in fact many of them shouldn't even survive the journey through Earth's atmosphere. But because they're traveling close to the speed of light, time dilates for them relative to us, which means they survive longer than they classically should, and we literally have observed this happening. Then we've got length contraction, which says that distances physically compress in the direction of travel as you approach relativistic speeds. So, from the perspective of somebody traveling near the speed of light, the universe itself actually becomes shorter, which sounds ridiculous, but mathematically it's a direct consequence of space-time geometry. And then probably one of the weirdest parts is the relativity of simultaneity, which basically means there is no single universal now. So there's no single universal point in time. Does that make sense?
Yeah.
So two observers moving relative to each other can disagree on whether two events happened at the same time, and both perspectives are equally valid depending on their frame of reference. And probably the most famous way of explaining all of this is something known as the twin paradox. So if we imagine one twin stays on Earth while the other gets into a spacecraft traveling close to the speed of light for several years before coming back. From the perspective of the twin on Earth, decades might have passed, but for the twin on the spacecraft, only a few years have passed biologically because time itself slowed down for them relative to Earth. So when they return home, they're going to be physically younger than their sibling. And this isn't science fiction or like a made up theory. It's literally a real thing. And the equations behind this have been experimentally validated over and over again. So the really important thing to understand before we go any further in this episode is that the faster you move, the stranger reality itself becomes.
Yeah, this is so interesting. I mean, I remember like we spoke about this on the time travel episode, and like people on the International Space Station like aging at a different rate technically to people on Earth.
Yeah.
But the twin paradox thing is actually insane though, because obviously would this be a reality? Because my immediate thought is, would the twin even make it back alive? Because we kind of spoke about this in the black hole episode. Like, what if we fell into a black hole? Like, would we even survive it? And like, likelihood is that no, we wouldn't really. But I guess we don't really know the exact answer. But like, hypothetically speaking, astronauts, they already have to go through ridiculous amounts of training just to kind of survive a rocket launch and survive a few months in space. So how on earth, like hypothetically speaking, would a human body survive traveling anywhere near the speed of light?
Yes, you are right. You are right. Actually, traveling near light speed wouldn't just be difficult or make you feel a bit sick like it would, for example, like when you send astronauts up to space in a rocket. But it would actually probably be, not probably, I actually think it would be, well, maybe similar to a black hole. So it'd be one of the most extreme environments a human could ever actually experience. Because like you said, even getting humans into low Earth orbit is incredibly physically stressful on their bodies. So we know that, for example, like during rocket launches, astronauts experience intense acceleration forces called G-forces, which happen because the body is being pushed faster and faster over a really short period of time. And your organs don't instantly want to move with you because of inertia. So your blood, your brain, your eyes, literally every part of your body actually resists acceleration. Now, at very high G-forces, blood can actually stop reaching the brain properly because of this, which is why fighter pilots can actually, or like they often can, black out. People can also experience like tunnel vision, nausea, obviously like feeling really sick, disorientation, and as we said, like a lot of them will lose consciousness. And that's at speeds that are absolutely tiny compared to the speed of light. The interesting thing, though, is that humans don't actually feel speed itself. We actually just feel acceleration. So if you somehow manage to accelerate gradually enough and eventually reached a constant relativistic speed, theoretically, your body might actually feel relatively normal inside the spacecraft. It's kind of similar to like being on a plane. Like once the plane reaches that cruising speed, you don't physically feel yourself moving because like everything around you is traveling at the same velocity. So the main problem is so the main problem is not necessarily existing at relativistic speed. It's surviving that acceleration phase and then surviving the environment around you once you get there. The reason I say that is because space is not empty. So even like interstellar space contains millions of tiny dust particles, things like atoms and radiation. And at relativistic speeds, even something microscopic like a grain of sand would literally become a deadly weapon because kinetic energy increases massively with velocity. So that means that a grain of dust traveling relative to you at near light speed would not behave like dust anymore. It would actually behave like a high energy projectile or like a miniature explosion. And the energy released could literally rip through your spacesuit. So let's just say we get to light speed, we're drifting through space in our spacesuit, but literally a grain of dust could literally penetrate through your spacesuit and tear through human tissue. So if you had like a load of sand, you go for I don't know why there's a sandstorm in space, but let's just say there is. You're traveling at light speed, you'd literally be ripped apart by like grains of sand.
Yeah.
And even individual hydrogen atoms floating through space would become really dangerous. So let's just say we're not just floating through space, we're in like a spacecraft, for example. At near light speed, hydrogen atoms, or just any atoms in general, could actually basically like literally rip apart your spacecraft. But they also carry enormous amounts of energy, producing ionizing radiation capable of damaging DNA and biological tissue. So without extremely advanced shielding, the crew would essentially be bombarded constantly by high energy particle radiation, and your cells would accumulate damage, and you would basically just end up getting cancer if you survived near light speed, which I feel like, as we've already discovered, that you wouldn't, but it's fun to think about.
Yeah.
Then we have the sensory side of things. So we've already briefly touched on this, but during long duration spaceflight, astronauts already experience disorientation because the brain relies heavily on gravity for balance. So your inner ear constantly tells your brain which way is up, but in microgravity, that system becomes confused, which is why space motion sickness is really common. Now, traveling near light speed would add another layer onto this because visually, the universe itself would start distorting due to relativistic effects. So the light from stars ahead of you would compress and blue shift, while light behind you would stretch and redshift. So not only are you surviving radiation and acceleration, but your perception of the universe itself would stop behaving normally. And all of this is before we even talk about the energy requirements, because according to relativity, the closer something with mass gets to the speed of light, the more energy is required to accelerate it further. And the amount of energy needed rises so dramatically that reaching the speed of light would require effectively infinite energy, which is why, according to modern physics, light speed travel for anything with mass is currently impossible.
Yeah, that is crazy. And when you actually said how quick the speed of light is, I was like, whoa, 300 million meters a second. Like, that is actually
crazy. I think they say it would take you like,
about.
was it like 7 seconds to get around Earth if you were traveling at light speed? I think, let me fact check that, but pretty sure that's what I saw. Yeah, mad.
That's crazy. One thing this is making me thinking is, obviously light is made up of photons, right? So if you're like, oh, hydrogen atom traveling at that light would like rip you apart. How light is probably like not the right thing to say, but like, what is a photon then? Because like that is light, and why are photons not ripping us apart? Obviously, I know it's different to like a hydrogen atom of like mass, but like, I don't know.
I don't know. I'm just thinking about like the chemistry of photons, but I don't think I remember anything about the chemistry. But I'm assuming it would be due to some kind of difference in chemistry. I guess it's mass. I don't know.
Yeah, I mean,
what is a photon?
I don't know, because like an electron is like part of an atom, right? Whereas photon, and maybe photon is kind of similar. I don't know. I think I'm just showing that I'm really dumb.
I really liked chemistry. Like, I loved it so much, and I really wanted to be good at it, but I just wasn't that great. I just about
I love chemistry.
I love it. I love it. Like, I really wanted to do well, and I put so much time into it. Like, I revised so hard, and I still didn't do that well. I only got a C in my A level.
Oh, I did chemistry for A level, and I think if I didn't go for medicine, which is like what everyone goes for when they are good at science and like don't really know anything about science careers, they just tend to like go for medicine. I kind of wish I just went for chemistry now, because it was my favorite subject. And
really?
Yeah.
What did you get in A level?
A.
Oh my god, I'm jealous. Low-key, I'm jealous, because I really wanted to do well in it. So
I way preferred it to biology,
but
I think it was because it was like you worked things out. But anyway, this physics obviously just blows my mind, because I don't have fundamental understanding of physics, to be honest. And then I think every time we like talk about it on the episodes, I'm like, well, this is absolutely mind-blowing. But I remember when we did our time travel episode and we spoke about relativistic travel and how technically it would basically then function like time travel.
Yeah, oh my god, I love that. I think about that episode all the time. That, you know, we were saying the other week, I think about the time travel episode, the simulation episode, and the consciousness episode all the time. Like genuine daily thoughts. I think about them 3 episodes.
Another one I think
So
about a
interesting.
lot is the origin of sleep. Like that kind of blows my mind as well, that one.
Do you know what? I think I need to go back and listen to that one again.
I think that's one of my faves. Because we
maybe I
spoke
should go back
about
and
all about
listen.
the organism in the sea that like comes to the surface in sunlight and then drops back down, and we think that's
Oh my
how
god,
we
yeah.
like evolved to have like circadian rhythm.
Yeah, I need to go back and listen to that episode again, I think, because like that is ringing about and I remember it being very interesting. Honestly, sometimes I wish I could just sit there and just binge all of our episodes. But for anyone who didn't listen to the time travel episode, one of the craziest consequences of special relativity, like Taz just said, is that traveling close to the speed of light genuinely allows you to travel into the future without needing a time machine. And the reason for that is a concept known as time dilation, which I spoke about briefly earlier. But this is the idea that time itself passes differently depending on how fast you're moving relative to something else. So the faster you move through space, the slower you move through time relative to people who are stationary. And again, this sounds fake, but as we've spoken about on this podcast before, it has been experimentally confirmed loads of times. And now one of the most famous experiments was the 𝗾𝘂𝗲𝗀𝗃 experiment in 1971, where scientists took extremely precise atomic clocks onto commercial airplanes flying around the Earth and then compared them to clocks that stayed on the ground. And the clocks on the planes ended up measuring slightly different amounts of time, exactly matching Einstein's predictions from relativity. So movement literally changed how quickly time passed. We also see relativistic effects with astronauts on the ISS or the International Space Station because they are moving so fast relative to Earth, time passes ever so slightly slower for them than it does for us on the ground. So astronauts on the ISS technically age a tiny bit less than people on Earth. I mean, we are literally talking like milliseconds, not years or days, obviously, but that effect is real. And once you scale those speeds closer and closer towards the speed of light, the time difference becomes enormous. Now, GPS satellites are another really good example because they experience both high speeds and weaker gravity than we do on Earth, which means their clocks drift relative to clocks on the surface of the planet. And scientists and engineers literally have to correct for relativity constantly because otherwise GPS systems would become inaccurate really, really quickly. So relativity is not just some weird physics concept. It does actually actively affect technology that we use every single day. And then one of the coolest pieces of evidence comes from something that I spoke about earlier, which is those subatomic particles called muons. So overall, if humans could somehow survive relativistic travel, you could end up in a crazy situation where maybe only 5 years pass for you on board the spacecraft, but when you return to Earth, centuries could have passed here. And I think Brian Cox spoke about this before. And just, yeah, it's kind of crazy. Like, think about if you traveled the speed of light, like, what would you come back to? Because literally you could come back and like, obviously everyone you know is going to be gone. But also like, would the Earth even be here? Like, do you know what I mean? Like, it literally would just be completely different. Do you know what I mean?
Yeah.
But I feel like the weird thing about that is that you would feel like completely normal. Like, you would still feel like the same age. You would biologically feel the same. So I just think that's such a weird concept because, yeah, if you traveled at the speed of light, you'd come back and probably everyone would be gone. Everything would be gone.
Everything would be gone. Yeah.
Everything would be gone. Like, maybe the Earth has been destroyed by an asteroid.
Yeah.
Where you've been gone.
Or there's like a completely different alien life living on Earth and doesn't even represent anything remotely human. That would be insane.
Or maybe we've like uploaded our consciousness somewhere and like the Earth is just, everyone's just
oh my gosh. Not this again.
Everyone's being cryonically preserved and like they're all uploaded to something.
Oh gosh. Honestly, we're getting really futuristic with our episodes, I feel like.
We are, but everything just leads there. Everything leads there.
Okay, so obviously we love these futuristic like thought processes, these ideas. So for argument's sake, let's say we somehow solved all the engineering problems and like all the biological problems, I guess. And humans could actually survive traveling near the speed of light. What would the universe even look like from the spacecraft? Because obviously you said like the way that we would visualize it would change it. So how?
Yeah, this is a very interesting topic. So yeah, it would just look completely different. So one of the biggest effects would be something called relativistic aberration. And I just love how all of these, like, there's just words for all of this shit. Do you know what I mean? Like, these are all theoretical, not theoretical, they are all hypothetical is the word I'm looking for. Hypothetical things. But I love how, like, physicists have actually given them all names. But relativistic aberration basically means that light would start getting compressed in the direction that you're traveling. So as I said earlier, instead of stars being spread evenly across the sky as we kind of see them now, they would appear to bunch together in a really bright, concentrated point ahead of the spacecraft. So it would literally look like the universe was collapsing inward in front of you. It's very like sci-fi. I think about like Star Wars and like
I was just gonna say that.
It would literally look like that. But at the same time, the light itself would actually start changing color because of something called Doppler shifting. So most people have actually experienced the Doppler effect, but with sound. So you probably learned about this in school in physics, but you know when an ambulance siren like sounds higher pitched as it's approaching you, and then once it's like behind you and it starts to go away, then it sounds like lower pitched. That is basically the Doppler effect, but with sound. But the same thing happens with light waves. So light in front of you would get compressed into shorter wavelengths, which is called blue shifting, which I mentioned earlier. But then light behind you would get stretched into longer wavelengths, which is something called red shifting. Now, at relativistic speeds, this effect becomes really, really extreme. So stars in front of the spacecraft would shift further and further towards the blue end of the spectrum and could eventually actually move beyond visible light into ultraviolet, X-rays, and even gamma radiation. So stars ahead of you would basically become really dangerous sources of high energy radiation. Meanwhile, the light behind you would redshift so dramatically that entire regions of space would literally fade out of the visible spectrum completely. So parts of the universe behind you would effectively disappear into darkness.
That is actually crazy because it really reminds me of Star Trek when the spaceship goes into like, what's it called? Can't remember what they call it, but they call it something and it like shifts into, I guess, like speed of light. And you literally see all the stars go whoom, and then
yeah, that would be it.
That's so weird. It's weird that these things are like based on like legit things, isn't it?
Yeah, I know. I feel like we need to do season 3 again, where we did like all the films.
I love that season. I think we should.
So did I. That was such a good season. I loved it. But yeah, Star Trek is accurate. Maybe.
I'm sure there's something inaccurate. Apart from the fact that it's literally a big old spaceship going at the speed of light, which is not very accurate, but there we go.
Yeah, well, that actually could also be based off of real science, because another thing about aberration is that it actually compresses light forward. So the sky itself would also start changing shape visually. So instead of seeing the stars spread naturally around you, it would look more like you are moving through some kind of tunnel of concentrated light. Now, physicists sometimes describe it almost like a cosmic spotlight effect, because everything ahead becomes brighter and more compressed, while everything behind you, like I said, becomes darker and emptier. So maybe Doctor Who and Star Trek, they're both right. Legit, and they're based off of this.
Okay, and now I think we need to answer the most obvious question, which is, could humans actually do this? Or is this one of those things that's like technically allowed by physics, but realistically probably impossible?
realistically, with our current technology, we are definitely nowhere near capable of sending humans anywhere close to the speed of light, because the amount of energy, like I said, required to move anything with mass towards the speed of light would just be absolutely enormous. So modern rockets work by expelling fuel backwards to generate thrust, but chemical propulsion is incredibly inefficient for relativistic travel. So even the fastest spacecraft humans have ever built moves at a tiny fraction of light speed. Voyager 1, for example, which is currently the furthest human-made object from Earth, travels at around 17 kilometers per second. But as we said, light travels at roughly 300,000 kilometers per second. So we are not even remotely close. Like, we are nowhere near close. But one of the ideas that scientists have explored is antimatter propulsion, because antimatter is unbelievably energy dense. So we spoke about this before as well. I feel like we said that about everything we do on this podcast now. We're like, oh, we spoke about this before. More of the story is listen to So Cultured and you will become very clever. You'll know everything. But when matter and antimatter meet, they annihilate each other and convert almost all of their mass directly into energy. So in theory, antimatter engines could be vastly way more efficient than chemical rockets. But the problem is that antimatter, as we've spoken about before, is incredibly difficult and expensive to produce. And the biggest problem is storing it, because the second it touches normal matter, it explodes. So at the moment, humanity has only ever produced microscopic amounts of antimatter. So that's probably out of the equation. So another idea is nuclear fusion propulsion, which is basically trying to harness the same process that powers stars. So fusion releases far more energy than chemical reactions, and some proposed spacecraft designs suggest fusion engines could potentially push probes to meaningful fractions of light speed. So scientists are actively researching fusion right now for energy generation on Earth, but creating a stable, controlled fusion reactor is already one of the hardest engineering challenges that probably we've ever faced, let alone putting one onto a spacecraft. Having said all of that, there is a really interesting real-world project called Breakthrough Starshot, which is trying to explore whether tiny ultralight spacecraft could be accelerated using massive lasers fired from here on Earth. And the idea is that instead of carrying fuel on board, powerful ground-based lasers would push reflective sails attached to miniature probes, potentially accelerating them still only to around 20% of the speed of light, which still sounds insane when you think about how fast that is. But even then, those are tiny unmanned probes. So you wouldn't actually be sending like someone to the speed of light, you'd just be sending something. And then obviously once you start talking about human travel, the timescales become a massive problem, because as we spoke about, even if we can travel at a fraction of light speed, the journey between stars could still take decades or century from Earth's perspective. So scientists have proposed ideas like generation ships, where multiple generations of humans would get on board this spacecraft, and like some of them would like die during the journey. Or they've also explored the idea of cryo sleep systems, where astronauts would somehow be placed into suspended animation. But right now, obviously, both of these concepts are massively speculative and probably just like fun ideas that probably won't actually happen, but maybe I'll eat my words. I don't know. But then we're going to get to the most famous sci-fi concept of all, which is the warp drive. Now, this comes from a real theoretical solution in general relativity called the 𝗾𝘂𝗲𝗯 drive, which is proposed by physicist Miguel 𝗾𝘂𝗲𝗯 in the 1990s. The really important distinction here is that the idea isn't about moving faster than light through space-time, because relativity says you can't do that if you have mass. Instead, the concept involves bending space-time itself. So rather than the spacecraft traveling through space faster than light, space itself contracts in front of the spacecraft and expands behind it, almost like the spacecraft is surfing a wave of space-time. Now, the issue here is that the equations appear to require exotic forms of negative energy that we've never observed existing in usable amounts. So at the moment, warp drive also remains entirely theoretical. No surprise there. But what's fascinating is that general relativity doesn't completely forbid the mathematics, which means modern physics is weirdly kind of in this place where faster than light travel seems impossible in one sense, but also not entirely impossible. So, in conclusion, if we were to travel at the speed of light, we would probably get killed by a grain of sand. But also, in reality, we actually absolutely currently definitely cannot even make it happen for many, many reasons. So I don't think any of us have to worry about traveling at the speed of light, because essentially it's not going to happen. It might happen in a few 100 years when our technology has evolved massively.
100 years, that's really optimistic.
Well, you know, we spoke before as well in the simulation episode about how, what's the word I'm looking for? How quickly we are now progressing. It's like gets quicker and quicker every single day. So 100 years could be realistic, harm. We could be traveling speed of light in 100 years. You never know. You never know what's going to be happening. We'll put the Shipley family on a ship and cryopreserve you all, and yeah, you'll come back to
be
an
honest.
emptier.
I'm telling you, my dad would fucking love that, because he is so into sci-fi. He would be like, absolutely,
Really?
sign me up on being on Star Trek. So yeah, love that.
There you go. Wow, that rounds off the final episode of season 8, What If. Thank you guys so much for tuning in. It's been very, very exciting. But before we do completely round off this episode, we have one more peer review take to do for this season. So let's get into it. This episode is sponsored by 𝘰, the smart citation tool for your everyday research needs. Taz, I don't know about you, but I think 𝘰 really sets itself apart from other citation and reference tools.
Yeah, I feel the same. With 𝘰, not only do you have access to over 250 million papers, but it can summarize a paper into a report, format citations, and more.
Yeah, and not only that, but I also love that you can connect it to tools like ChatGPT, Claude, or Copilot, and it basically just upgrades how those tools actually handle research.
Yeah, so instead of getting a general answer, your AI is actually searching through a huge database of research papers. And the key thing is it's not just looking at the titles or abstracts, it's searching inside the full text.
Honestly, it's such a slay, because it just makes such a big difference, because a lot of important details don't really show up in abstracts, and I feel like most tools just miss that completely.
On top of that is the smart citations feature, which I think is one of the most useful features, because it doesn't just show how many times a paper's been cited, it also shows how it's been cited.
Yeah, you can see whether other researchers have supported the findings, contradicted them, or whether they've just mentioned them. So it gives you a much clearer picture of what other experts in the field feel about it.
It also helps with access. So if a paper is available to you, 𝘰 will help you get the full text.
So if you want to try it, you can head to 𝘰.ai, or you can find the link in today's episode or video description. Setup only takes a minute, and you can use the code on screen now for money off. And thank you so much to 𝘰 for sponsoring today's episode. But for now, let's get back into it.
But I'm worth it, 'cause I'll slip into your dreams tonight.
Alright guys, you should know by now that peer review this take is basically where we read out your hot takes from the lab, tech, academia, or the workplace, and we either give it minor revisions, major revisions, or straight up reject that hot take. So let's get into the first one. Using the last of a reagent without ordering more should be punishable by death.
Oh my gosh. Wow, that's some pure passion right there. Jesus Christ.
That is some real passion.
That's a bit extreme, can't lie. That's a bit extreme.
That's someone who's been burned before by like people who just don't read the stuff in the lab. I do
also,
get
this
it,
person
it's
is
annoying.
this person is 100% type A, like cannot sympathize with a type B at all. I would 100% be that bitch to like accidentally use the last of a reagent and then like forget to order more. So please, no, I reject.
I'm not gonna lie, I am that person who just doesn't really like using communal lab stuff anyway. I like hoard my own stuff, like order my own stuff, hoard my own stuff, so that like
You don't
no
have to deal
one
with
can
this.
use it. So
But
maybe I'm even
maybe
worse.
some labs like you're not allowed to do that. Like some you know.
Yeah. Doesn't
I
stop
don't know.
you
I
from
don't work in
doing
the
it,
lab,
though.
guys, so I don't have to deal with this stuff. But I can see why it would be very, very annoying. But punishable by death is a bit extreme.
Yeah, I'm gonna give this major revisions.
Major revisions. I'm straight up rejecting.
Okay. I'm giving
Too
it major
extreme.
revisions because it is very annoying, but I'm not sure I agree with the punishable by death part. But yeah.
No. Who are these
Okay.
people? Who listen to this podcast?
Yeah, they're actually all a little bit morbid this week. So,
are they? Okay.
Yeah.
Go on. What's the next one?
So the next one is the PI saying that should only take an afternoon is one of the leading causes of scientific depression.
That is scientific. That's such a scientific statement. I thought they were going to say like leading causes of like heart disease or something like that. Is such a scientific despair. Oh my gosh. To be fair, I think that like it does trigger me hearing someone say like that should only take an afternoon, because the amount of times my PI used to say to that to me, and I'm like, yeah, it would only take you an afternoon because you've got 20 fucking years experience. I barely got a year, babe. This is going to take me 20 afternoons. Like,
or
what the hell?
on the flip side of that, you have no fucking idea how long it would actually take. You're just like plucking an idea out of your head and you
Out
think
of
you could
thin
just
air.
do that. Yeah. Like I
Now,
remember
see-
like one of my old supervisors, he was like, oh, you should do like this. And I went and met some other like supervisor, and she was like, that is a whole PhD in itself. Like,
Oh my god.
no. And I was like,
No.
oh, okay. He was saying like it was some simple thing, but yeah.
No, I hate that. The thing is, my supervisor who used to say that to me, like that should only take an afternoon, was like he knew exactly what he was doing. And I was thinking, well, can you just do it for me then? Because I know this is going to take me 20 afternoons. And I would spend 3 afternoons on it. Then I would have a breakdown and I'd say to him, I'm really sorry, I can't do this. We'd jump on a Zoom call and he would do it in 5 minutes. And I'd be like, oh. And I'd feel so fucking stupid.
Yeah,
and you know what that
there
did?
is
That
as
did lead me
well.
to scientific despair. So, except no revisions. I agree.
Accept. No, I
Traumatized,
agree.
honestly. Traumatized.
Because what else is like the leading cause of scientific despair? I guess like it's not stuff not working, but if there was no pressure on it
Just
having to
science.
work in an afternoon, then it would be fine, wouldn't it? So
True, but I mean, you know, diamonds are made under pressure, so it would lead me to work pretty hard. Can't lie.
yeah. Okay, so accept, I guess.
Except, yes, correct.
The next one is quite funny actually. So peer review this take. English is not my first language, so warning signs and SOPs do not apply to me.
Fuck's
That
sake.
is
What's an
pretty
SOP?
savage.
What is an SOP?
Standard operating procedure. It's basically just like outlines exactly how you're supposed to do a procedure within like the safety requirements and stuff.
Listen, babe, if you can write a scientific paper, you can read a warning sign. Can't lie. But also, if it's a warning sign, like surely that's something for your own safety anyway. So if you don't want to read it, then pop off.
Yeah, no, literally.
But,
it's kind of like
I
the
mean-
first review, like peer review this take that we did, that was like, I can't be bothered for things I can't be bothered to wait for things to cool down, and like,
Oh
you're
my
just
god,
gonna
yeah.
accept burning yourself. Like,
Yeah.
Okay.
If you want to burn
Do that
yourself,
then.
go for it. But also, I can't lie. If I say I learned French and then I went to France and I was working in France and like everybody speaks French, I'd 100% like just play dumb at like certain moments. Like, I'd be like, oh, sorry, I can't understand. Someone's like, can you do this? Like, really need your help on this. Oh, I'm really sorry. Like, I'm not sure what you're saying.
or like if they ask you a question, you have no idea how to answer it. You're like, no comprendo, which is actually Italian for I don't understand. For no, is it? Was it Spanish?
100%. That
Oh, I
I'd
don't know.
100% do that. Like, definitely. Like, if English is not your first language and like you're in like an English speaking environment and you don't use that, like, props to you, because I'd be doing it all the time. Like,
Bro,
I'd literally
I've
use it as
actually
an
thought
excuse all
about
the time.
this, like, not in the scientific setting where I've been in a place where I don't, like, maybe abroad, and I'm like, what if we get caught doing this and it will get in trouble? And I'm like, we'll just be like, we don't understand, sorry, don't understand the language.
You can't do that though, because everywhere in the world, like, all the signs are in English. Like, there's always an English sign, so we can't.
Oh, I'm
as
not
English...
pretending to be English though. I'm pretending to be
Oh.
maybe like some, I don't know, some other
I don't think that's
language.
going to work with our accent though. Do you know what I mean? Like, no comprende. They'll be like, you're fucking British.
Me don't understand.
No, that was so bad. That was so bad. Oh, it's giving
Okay,
like when you were a
fine.
kid and you used to like make up a language with your sister. Do you know what I mean?
Literally.
Oh.
100%.
Now, listen, if you have to learn a new language and come and live somewhere and work somewhere, especially somewhere like academia, where there's like, you know, the language is confusing even someone whose first language is English, then do you know what? You are allowed, like, I'm giving you a pass. You're absolutely allowed to pretend that certain things don't apply to you because you're confused. Absolutely. You deserve that because you're already in a hard environment. So,
I mean, I don't know about warning signs, but like, I mean, that's on
if they
you
want
if
to
you
do
don't
it.
want to follow that.
If they
but-
want to do it,
Do you know
they
what
can
I
do whatever
actually
they want
saw
because they're great.
the other week on that kind of relates to this was some, I can't remember who it was. It was another STEM influencer, and she posted that she was doing her thesis defense in one language, but for like scientific terms, she only knew the English term. So she was like, I was speaking in like Dutch or something, but I would then have to like flip to the English terminology, like scientific
saying, it's
terminology
hard
for certain words. And I'm like, God, that would be like so confusing and so hard.
Yeah, this is what I'm saying.
Like,
These people
yeah.
deserve way more credit. Like, I remember like when we used to like do like actual peer reviews, and like I think the amount, like, you know, sometimes you can see other reviewers reviews, and like the amount of other reviewers who would be really rude about like their grammar or their like way of writing, and it's like it's really obvious that English is not their first language, so like don't be so rude about it. Like, it used to piss me off. Except
Yeah.
you can do what you want because you're great. That's me.
We're accepting. Okay.
Except
Rogue. But we'll take it.
Yeah.
Okay. So final peer review this take of the
Oh my
season,
gosh.
guys, is, yeah, I don't know, not that much of a hot take, I would argue, but okay.
Okay, give it to me.
It says, the real purpose of lab meetings is to professionally explain why nothing worked this week. Accept. Because why is this
Accurate,
literally every lab meeting? It's like, my experiment didn't work, and then everyone chimes in as to why they think it didn't work. Like, that's literally it every week, right?
I mean, at least you have people chiming in with why it potentially didn't work. That's great. But yeah, lab meetings is literally like, this is how it goes. You spend all week stressing. You can't do anything, like failing at things. You spend the day before the lab meeting going fucking mental trying to fix everything so you can have some data. Like, you're literally so stressed. Like, it's the most stressful day of the week. And then leading up to the lab meeting, you like have it all wrote out. Like, you're trying to explain, like make it seem like you've not done anything, because you've not done anything. Everything's just failed, and it's just like a whole stressful experience. And then you leave the lab meeting and then you spend the next few hours doing jack shit because you're just so anxious from the past few days, and then you repeat.
Yeah. And then you're like, why did I get so wound up about presenting basically negative data in the lab meeting? And like, it takes ages to decompress after, but like every time you present in the lab meeting, it's the same thing.
Same thing. It's just a vicious
and it's
cycle.
the same thing for everyone else as well. Like, everyone is like,
so what are we so stressed about? Everyone's failing.
I don't know,
We're all just failures in a sea of failures. It's fine. It's fine.
It's fine.
But yeah,
I mean, a lot of the time
accept.
science does failed, right? So
yes.
Yeah, straight up accept. I completely agree with this. That is the
love
only point of
that.
lab meetings. But
I love
yeah.
ending on an acceptance of the hot take. Guys, thank you so much for sending in all of your hot takes for this season. I've absolutely loved this laboratory segment for the season. I'm wondering what we're going to come up with next season. But if you guys have any ideas of what you would like us to do, then definitely make sure you pop us a DM on Instagram or TikTok on @soculturedpodcast. But that rounds off the final episode of Season 8, What If. Thank you guys so much for tuning in. We really appreciate it. We really appreciate you. And if you have enjoyed this season or any of our past seasons, please do consider giving us a rating or review. And as we said at the start of this episode, we will be back with Season 9 soon. So make sure that you're following us on social media so that you can stay up to date with the theme for Season 9 and when the first episode of Season 9 is going to be coming out. Lastly, make sure you follow us on whatever podcast platform you are listening to us on so that you do not miss when Season 9 comes. But yeah, thank you guys so much for tuning in, and we will see you in Season 9.
Bye.
Bye.